Good afternoon, students. Welcome to the first live session on database management system. We have received many queries for this particular session, many of which we will be discussing today, and some of which we cannot complete discussion in span of 1 hour. So, we will post them as announcements in different links after this particular session by a few days. So, let us go straight to the queries that we have made, and we have actually organized all your queries in terms of the different modules or the different concepts of DBMS. So, it is not really sequential in terms of your day or time of query. We are going to present you the queries in terms of the topics. So, the first three questions were like why do we need DBMS, what are the purposes of it, what are the advantages of it. These are the two questions that we got, and I think these questions are well answered in either the textbook by Korth, Navate, whatever textbook that we can read, as well as they are nicely covered in the slides in the lecture materials as well. However, I will just make a brief note on what is a database management system and what is the basic advantage or purpose of it. Now, I would say that database management system consists of a number of correlated interrelated data and a set of programs to access this data. Before DBMS was invented, we had a very similar, but not so powerful way to do the same thing, which was called programming in a particular language and the file system that we had, flat file system I would say. And for example, in the last kind of 30 years back, probably it was all COBOL if you look at it. Idea is I can create a number of users as administrators and as normal users, and they will maintain the database, they will query the database, they will edit it, they will insert data, they will update data, and they will delete data. These are the minimum tasks that a database management software must do, but it does a lot more than what I said. For example, it controls redundancy. After all, if we design a data in a very rudimentary manner, then the same data would be available in many places, maybe necessarily or maybe unnecessarily, and we have redundancy. Now, redundancy basically implies that we have inconsistencies, because if there are redundancies, if I want to change one, then I have to change all occurrence of the same data wherever it is. So, controlling redundancy actually leads to a consistent database, and the traditional file system plus programs like in COBOL does not allow you to do that in a very effective manner. Then for example, in a database I have role based access control, that is one kind of an access control, which says that a particular user has a role in a particular database. Maybe a user has some permission to read a particular table or a few tables. Some people probably have authorization to create, edit table structures. Some people may have authorizations to update certain tables. Now, this is called role based access control. Such mechanisms are inbuilt to a database management system, but they are not inbuilt to any file system plus programming kind of an environment. Now, we also can have multiple user interface, and that involves what is known as view. I think some of you, or at least most of you, know the concept of a view. My database may contain let us say 100 tables, and even a table may have more than 10 attributes. Now, I am a simple user of this particular database. I need not look at all those 100 tables. My role is to view, edit, update, delete only 5 tables out of those 100 tables. So, I can create a view in which I am supposed to look at only those 5 tables, or not necessarily 5 tables as a whole. If you a part of the file table 5 tables where some attributes are visible to me and some attributes are not visible to me, which is not under my jurisdiction. So, these different multiple user interfaces can be provided by a database management system, which is not so easy by a traditional file system plus programs. Also data has complex relationships. Some data has a relation, I mean some tables have relations with other tables in a very intricate manner. Some tables are not so related with some other tables. So, these kinds of complex relationships can be maintained in database management system in a much more intuitive, much more natural manner than anything else. Then there could be integrity constraints in a data in a file. For example, a few attributes in a table cannot be less than 0, a few attributes in another table cannot be more than 100. Some attribute is basically a date, where the content or the value of that particular attribute cannot be anything other than a date. So, these are simple integrity constants. Even more complex integrity constants may actually occur, and those kind of constraints can be naturally expressed in a database management system between tables, inside one table, even sometimes across two different schemas. And any database management system is fault tolerant in the sense that if the system crashes, then it has recovery mechanism, it has rollbacks of activities being done and activities may be done in the distant past. So, that the database can be made to go to a consistent state, and from that the transactions which are supposed to be fired on it beyond that particular time point can be fired. So, all these possible I mean there are more actually, but these are some of the most important highlights or advantages of a database management system, which differentiates it from the traditional file system plus program kind of an approach of using data. So, these are also mentioned, as I said, in any textbook in a very elaborate manner, as well as our NPTEL video plus the slide materials also covers many of them. If you cannot understand a particular point of it or a number of points of it, then you can easily throw a question on the forum, and we will be happy to answer that question giving concrete examples of that particular aspect. So, now let us go to the next question, which is for abstraction level. The question is, we have read probably that there is a physical level, logical level and view level, abstraction level, and the question is why they are called abstractions and what are they basically. Now, to answer that question, I will go to this slide, but before I mean this picture, but before that let me remind you that abstraction is basically exhibiting a model of reality. For example, when you write a programming language, you say that A is an integer. Now, you must understand that in the basic computing system there is nothing like an integer, and we only have bits and bytes there. So, we can store probably a few bytes of data somewhere, maybe contiguous 4 bytes of data. We consider this to be an integer, and when I write a high level program, I write A as an integer, which may be a 4 bytes long space in the computing system, which contains only bytes. So, mathematical integers are not really I mean exactly available in a computing system, but we do not need to know exactly how an integer is represented in a computing system to write a very nice program in a high level programming language like Java, C, C++, etc., and make the problem make or solve a problem. Now, similarly here, after all, we, for example, we write tables, we say that there are 4 tables, in each table these are the primary keys, these are the different functional dependencies that we might have. These are conceptual, these are logical. After all, if you think about the disks where the tables are stored, they do not store them in exactly those kinds of logical names, number one. And the second thing is, if you have, for example, if you say that this is my primary key, then that has very little sense in the internal or the physical schema that it has. Now, for example, I think you are now in week number 6 or so. So, maybe you have seen things like index. For example, probably you have gone through the B plus tree, B tree for example, then primary index, secondary index, the cluster index, these schemes. These schemes relate a lot to the physical storage organization of the database management system, which actually relates to the external schema. While the first part of it, and I mean we will go through transactions as well, the first part of it I mean SQL, SQL, then the relational data model, then the tables, then the normalization, all these aspects are basically related to the conceptual schema. That is the logical part of it. Now, even on top of this logical schema, there are a view in which, as I said, if there are 10 tables and I am a simple user of that particular system, I may not know all those 10 tables. Maybe my work, my tasks is on only 4 of them. Therefore, I am given a description or a role of editing, deleting, manipulating only 4 tables out of those 10 tables. So, that is a view, and probably to me the entire database is just 4 tables, because that is a complete view, that is a consistent view, but that is the view that I have. Another person who may be a little more senior, a little more involved in it, may have a view of 8 tables, another person may have a view of all the 10 tables. So, you see everybody thinks that the table, that the schema, that the entire database is 4 tables large, 8 tables large or 10 tables large, but only one of them knows the whole picture, and even that person knows the whole picture as far as the logical view of the database is concerned. That person does not know how those tables are stored in physical disks, that they know, that he or she may not know. So, everybody has a view of the database at his or her level, but to them this is the complete understanding of the database, but actually the database is a lot more than what that is at a physical level when I go to the disks and the storage of the particular data of those tables. So, that is the abstraction level, and here we have 3 levels of abstraction: external schema, which is physical; conceptual schema, external schema, which is the view; in conceptual schema, which is the logical; and internal schema, which is the physical storage structure of the database. In our course, we primarily look at, mostly 80% of the course is dedicated to conceptual schema, a little of it is dedicated to internal schema, and even less is dedicated to external schema or the view schema. So, now we have a number of questions about schema, relation and instances. People, I mean students, are unable to distinguish among these three different terms, which is very essential for a database management system student. So, basically there are 3 important terms: schema, relation and the instances. I think many of you write SQL queries. So, let me tell you, if I say I am designing a database for the department, then there are many tables in which I need to design for them. For example, the department kind of a table, where the department name is stored, the building name is stored, the budget is stored, etc., etc. So, that is a table or a relation. One table is basically nothing but a relation, and rows of a table are called tuples of that particular relation. Now, a number of such relations like department, faculty and many others, they comprise the schema. So, a schema is a number of related tables which are used to model a particular database, that is a schema. So, what is larger? Schema is larger. Schema has a number of tables or relations for a particular database. Then schema, that schema, then comes relation. One relation is one table, and then comes instance. Now, instance is the actual contents of different tables of a particular schema, right. So, if you say that there is a relation called department, then I have at a given point I have maybe biology department located at Watson building, budget is 90,000 whatever INR or USD. Then I have computer science building Taylor, budget is 100,000. Electrical engineering department name Taylor, budget is 85,000. That is today at this point of time. Maybe 2 more departments are there. So, these are the instances of the the particular table department at a given time. Maybe tomorrow this may increase by 1, this may decrease by 1, even the contents may be changed, maybe the building changed for the department biology. So, instance is the most frequently changed entity in a database. Now, given that this department, this example tells you the instance of one relation, but however, instance basically says instance of a database which is such contents at a particular point of time for all relations of a schema. That is the instance of that database. So, we have many tables, many table formats, many table. When I say just table, I only mean the header row of that particular table which contains the names of the columns and the name of the table. So, that is a relation. The different values which when I populate in that particular relation or in that table, it becomes an instance of that particular relation. Many instances of a relation or a table gives me the relation for the instance for a particular database. I may have in my project many databases or many schemas, that is also possible, that is quite natural. For a large project I might have a number of database, meaning a number of schemas, and therefore, I mean this is kind of hierarchical development of the models of the data modeling. So, we should go to another key concept which is key, KEY key concept, which is key. We have concept like super key, candidate key, primary key. Now, if I look at a particular relation R, then and I say K is a super key of R, then I basically mean values for K are sufficient to identify a unique tuple of each possible relation of that particular relation capital R. So, I mean the attributes in K, if they are the same in two, there cannot be any two tuples where the attributes of K as a whole is the same, they are unique for every tuple. Now, this K is a candidate key if K is minimal, and any candidate key I think we can choose as the primary key. Now, how to find out this K? How to find out this K? One answer could be in general, I mean typically, if I say that all the attributes of a particular relation, if I take all of them together, possibly they are different, most often they are different for every tuple. So, therefore, all attributes taken together will be naturally a super key, but question is it minimal? By that I mean, if there are 5 attributes in a relation, can I have 4 attributes, so that if these 4 attributes are not are always unique in the given instance of that particular relation, that is a question. If the answer is yes, then those 4 attributes can serve as a key. Now, that is the idea of key, or ways to generate a key, find out a key given an instance. Now, keys are however not found out from the instance normally. Normally when I model a database, I model different entities in terms of different tables. Even the relations are also implemented or modeled in terms of different tables. Now, the moment I say that there are tables, then in that table there are obvious functional dependencies, you have also learnt about it. These functional dependencies comes from the model of the problem domain. For example, if I think about a simple relation or a table which has student's roll number, student's name and student's marks, just that, and a registration number. Maybe registration, maybe I mean it is normal, registration number of every student will be different. So, I can say registration number alone can uniquely identify one tuple or one row of that particular table. So, registration number alone is sufficient for acting as a key, candidate key or as a primary key. Also, I can say that the roll number and the name is unique in every row, right. In that case, roll number and name together also forms a candidate key or a primary key. Any candidate key can be chosen as a primary key, right. So, also I can say registration number, roll number and name, that is also a super key, but it is not candidate key, because it is not candidate key because a part of it is sufficient to become a candidate key, it is a super key. Registration number is a candidate key, roll number and name is a candidate key. If I choose all three of them, then it is a super key, but not a candidate key. Why not a candidate key? Because candidate key is always a minimal. By that I mean, if I delete one attribute from this candidate key, even then that the value of that particular candidate key is unique in all the records of that particular relation or that instance. So, we will have an opportunity to look at primary key in one more question that we have already received for this live session. So, we will defer this discussion again to that point. So, I have an example here, it is student name, roll, marks, and if you look at it in this instance, you see John and roll number gives me 100 marks, Maya and roll number gives me 100 marks. Now, so if I say just name uniquely identifies all the tuples, then you see if I say marks is 100, then John can have that 100, even Maya can have that 100. But if I say John and 25, right, Maya and 18, they together I think becomes the even John, I mean, right, John is unique in all these rows. So, John could be a candidate key, Maya could be a candidate key, I mean name could be a candidate key, name roll could be a candidate key, even I think roll is also a candidate key, because you see in this particular instance roll is unique in all these records. So, what are the super keys then? It is a strange situation, I mean it is a kind of atypical situation where name is a super key, roll is a super key, name roll is a super key, name marks is a super key, roll marks is a super key, name roll marks is a super key. Now, who are the candidate keys? The minimal of them. So, if I say just for argument's sake name marks is a candidate key, it is not, because if I delete marks from this particular name marks combination, then I get name, and name is also a super key. So, name marks together is not a super key, name would be a super key. Out of these super keys, take one in which no attribute can be deleted, and even then it remains a super key. That is the I mean point to be understood. Take any one of them, roll marks, let us say delete marks, then I get roll, and roll is also in this list of super keys. So, what does that mean? That means roll marks is not a minimal super key, I can minimize it even further, and therefore, in roll marks is a super key, but not a candidate key, roll is a candidate key. Now, can I delete roll? No, I cannot delete roll, because if I delete roll, marks is not a super key, but that is not the question. Which one I delete is not a question. Can someone be deleted? That is the question. If the answer to that question is yes, then the super key is not minimal. The question is, can I delete one attribute from the super key, and even then the remaining part of the super key remains another super key or not? That is the question. If that question is answered affirmatively, yes is the answer, then this is not a minimal super key. If the answer to that question is no, then the super key under question is a minimal super key. So, that is the candidate key, and primary key can be chosen from any candidate key, that is not a problem. Any candidate key can act as a primary key. Now, surrogate key is something which is a little artificial, and when a key, I mean natural key is not there, which is not normal, but it is possible that the natural key is very long, non-numeric, and may change over time. Then we do not use that primary key as a whole. So, we actually use then an artificially generated key, for example timestamp could be, or a counter which goes on increasing monotonically increasing, which never decreases. Such counters or timestamps we can use, which are unique in all rows of that particular table, and hence it can act as a surrogate key. There are advantages and disadvantages of getting a surrogate key. Surrogate key is simplest, most desired advantage, it is very small, it is short, and therefore, it is crisp, but it is not, it does not come from any natural modeling. Therefore, it does not have any logical significance. Moreover, surrogate keys are not easy to associate in terms of referential integrity. When you have two tables and you want to connect them by referential integrity, surrogate keys do not have much meaning there, right. So, there are advantages and disadvantages of surrogate key, but sometimes the naturally occurring key is too long and non-numeric and may change, and then we use surrogate keys in those circumstances. Also, we use surrogate keys in data warehouse, where we cannot delete any data, and therefore, there cannot be any primary key really, because there will always be there will always be rows where even the primary keys, naturally occurring primary keys will be duplicated. In those cases, timestamp can be used as a primary key. Data warehouse uses surrogate keys very frequently. We had a number of joins, and it is a very common concept, but we have asked this question. It is a common question as well. Last year also we had this question, and we had these slides as well. So, join, as you know, natural join, basically it is a Cartesian product, a subset of the Cartesian product. Now, we have two relations, therefore, since it is a Cartesian product of two sets, two relations. So, you look at these two relations, and if we have a natural join, then which will come, those tuples will come in which the lone number, which is a common attribute, is the same. So, if I take a natural join, I will get L 170 Jones downtown 3000, as well as we will have L 230 Smith Redwood 4000. These two tuples we will get. Now, if we make a left outer join, then it is a Cartesian product in which all tuples or all rows of the left operand in that Cartesian product will occur. Naturally, L 260 will occur therefore. Now, L 260 does not have any entry in the borrower relation. So, therefore, the attributes which are coming from the borrower in that case will become null. So, if I look at it, you see, therefore, L 170 and L 230 will come as they came in natural join. L 260 will come, but remember that L 260 was there in the borrower relation, in the loan relation, but not in the borrower relation. Since it was not in the borrower relation, the customer name was not present, and since customer name was not present in the outer join, customer name is stored as null, right. Similarly, that is the case for the right outer join. If I do a right outer join here, then all entries, all rows of the borrower will come. So, which will come? L 170 will come, L 230 will come, L 155 will come. Now, L 155 does not have any entry in the loan relation. So, in the attributes for branch name and amount, For L155 the entries will become null, and let us see whether it is something like that only. Yes, look at L155, the branch name and the amount which comes from the loan, that becomes null now. Now, a kind of union of the left outer join and right outer join is the full outer join. Now, the definition of these outer joins are easy to understand. A little more important is to understand when we use them. When we use natural join is quite obvious to you, because we have written so many queries in which natural join was required. Whenever you are consulting two tables with certain commonalities or certain conditions relating them, the query will have that, then we use natural join. But when is the situation when you use, for example, a left outer join or a right outer join, things like that. Now, in this table which you are seeing here, now if I want to know, if I want to know all persons who have a loan as well as who are and the customer names for them as well, right. I mean, this is not a good example actually. For example, if we have a table where we have savings accounts of a number of customers and we have loans for them. So, a certain savings account, we have the account number as well as the customer name, and the loan account will have the customer name and maybe the loan amount, and I want to know names of all persons who have either a savings bank account or who have loans. It is kind of a union, who has savings bank account holders and who have loans, but you cannot do a union because that these two relations do not have the same attributes. We cannot do a union therefore. Then what can I do? I probably can do an outer join here. If I do an outer join and select only those entries that I need by projection operation, then I can have all the customers who have a savings account as well as the customers who have loans. That can be done by a full outer join, right. So, you should think about when is it used rather than what are these. So, what are these is the first thing, but second level question is when are these outer joins used. Think about it. If you understood my answer, my response to when do we use full outer join, well and good. If you do not, then do not hesitate to post a question in the forum, and we will explain you again the circumstances where these outer joins are used. Now, data anomalies was the second was another question, and we have now normalization questions as well. So, three types of anomalies are there: update anomaly, insert anomaly and delete anomaly. We have a simple relation employee project, and by this we are trying to explain you what these anomalies are. This is a very simple relation where employee number, project numbers are there and they form together, they form the primary key. We have employee name, project name and number of hours as other attributes. Now, if you think that a project name for project number 1 P1 is changed, has to be changed from billing to customer accounting. So, how many P1s are there? Maybe there are 100 employees who work in the project P1. So, this table will contain 100 rows where P1 billing is present at a given point of time. Now, when I change one of them to customer accounting, I have to change all of them, 100 of them to customer accounting as well. So, this is update anomaly. Now, what is insertion anomaly? See, I want to add a new project has come, but no employees have been associated with that particular project as of now. Can I insert that project in that employee project relation? No, because the moment I want to insert a project with a project number and a project name, employee number has to be inserted. Why? employee number is a part of the key and I cannot keep it null. Therefore, I cannot insert a project unless an employee is assigned to it. Similarly, I cannot insert an employee unless that particular employee has been assigned to a particular project. So, this is insert anomaly. What is delete anomaly? Now, if I delete a project delete a project. So, what will have to happen? I have to delete all the employees who work in that project. If a project is deleted, then employees working in that particular project are mandatorily deleted, because otherwise we have to have null values, something like that, and our primary key cannot have null values there. Similarly, if an employee is the sole employee of a project, I cannot delete that particular employee, because the moment I delete that employee, the information about that particular project will be lost. We cannot store that now. So, this is a table where all sorts of anomalies are present, and role of normalization is to make a situation where such anomalies are not present, or the presence is highly reduced, mitigated, as well as redundancy as a whole is reduced. So, then comes partial dependency. So, I will take this as a part of normalization. Now, if I have unnormalized relation, then you know the attributes can have a number of values, which is every attribute can, I mean in a row for an attribute you can have only one value, we cannot have more than one value. The moment I have that, it is 1 NF. In 1 NF I remove partial dependencies, I get 2 NF. In 2 NF I remove transitive dependencies, I get 3 NF. Now, I basically go to Boyce code BCNF in a way, but BCNF by definition of that is a 3 NF plus something, plus minus something, it is plus minus something, it is 3.5 NF it is called, but it also it has some good things about 3 NF, but it also has a little the bad things which is not there in 3 NF. So, this is how we do it. So, our idea for normalization is to avoid or mitigate the chances of insert anomaly, delete anomaly and update anomaly. So, we will talk about, I think we do not have it. Yeah. So, this is in 1 NF, and the moment I have that, I mean this status you can think of this as a code. I mean, so this is supply details, S number, city, P number, quantity, and the status code. I mean, maybe you can think about this as a pin code as well assigned to a city. It is just a code for that particular city. So, from the model I can say, given an S number, the city where the supply is located and the pin code of that particular city is all understood. So, S hash functionally determines city comma status, and similarly SSP has right arrow quantity and city right arrow status. So, these are the functional dependencies that I have. Now, what is the key? The key here is, I think, S number and P number together. If you look at it, this is S1 P1, yes, S1 P1 is unique, S2 P1 is unique. So, the key is S number P number, that is the key. Here it is written as well, S number P number. Now, if you look at it, one functional dependency is S hash right arrow city comma status. Now, what is very interesting in this particular case? The interesting thing is that a part of the primary key is present in the LHS of the functional dependency, and the right hand side of the functional dependency has non prime attributes. Now, this is called partial dependency, and this partial dependency gives rise to insert anomaly, delete anomaly, insert anomaly, update anomaly, and a huge redundancy. So, that is why we like to remove this partial dependency. How? By breaking the table. Not we cannot reorganize the table just like that. We have to break the table into two tables, so that this partial dependency is not there. So, then we get 2 NF. So, you see now what we have done, S number P number gives me quantity, and S number, S hash gives me city and status, right. In first table, S hash P hash is the key, primary key. In the second one, I think S hash is the primary key, right. So, now we do not have the functional dependency that we had. S hash to the right hand side of the functional dependency, and the right hand side is city and status. That does not happen anymore, and therefore, we have two tables now, both the table are in 2NF. Also, I think if you look at it, the size of the table right now is a little less. I mean, you can count that, I guess. You see how many rows? 1, 2, 3, 4, 5, 6, 7, 8. How many columns? 1, 2, 3, 4, 5. So, 40 entries were there, and now it is 1, 2, 3, 4, 5, 6, 8 into 3, 24, 24 plus 3, 24, 24 plus 9, which is 33. So, you see the amount of information that I was storing has reduced. Right. Previously, it was 48 into 5, 40. Now, it is 8 into 3, 24 plus 3 into 3, 29 plus 9. So, 24 plus 9, which is 33. Redundancy is reduced actually. Then we have 3NF. So, we have to it is in 2NF, it has to be in 2NF, but then there could be transitive dependency. Transitive dependency is non-key attributes are functionally dependent on the primary key, but that is done in a transitive manner. So, non-prime attribute or non-key attribute is to be so that means basically key I mean non-key attribute is dependent on the primary key. So, in this case why it is such, you see that S hash, I mean city is dependent on S hash, status is dependent on city, and status is dependent on S hash. So, you see it is a transitive dependency, status is dependent on S hash. So, we need to reduce this dependency as well. I mean in the second table, it is the second table actually. In the second table, you see the status is dependent on S hash, and that is what we do not like, because basically status is dependent on the city, because every city has a different status. So, we need to change it to 3NF, and then what we need to do is we need to break this up into two parts. In one we have S hash and city, and the other one we have city and status, right. And this again you need to think a little, reflect a little what anomalies are absent here. Frankly speaking, this does not reduce the space. Redundancy is not much reduced in a transition from 2NF to 3NF, but a little more anomalies are reduced in this case. So, you need to think about it and then figure it out. You can use the book as well as the slide material, or you can send a mail to us in the forum, where you can explain you further. So, the BCNF is also another normal form which says that the beta is dependent on alpha. This is valid for any one of the two cases. In one case it is trivial, which is not much to discuss about. In the other one, alpha is a super key for R. The second the most important case in this BCNF is that alpha, the left hand side of the functional dependency, is a super key for R. So, that is nice, but that is okay. So, only thing is which one is good, BCNF and 3NF. In general, BCNF is good, but if I compare it like this, then 3NF we have decomposition is lossless and the dependencies are preserved, all the functional dependencies are preserved. Now, in BCNF we can have examples where decomposition will be lossless and we may not preserve all dependencies. Sometimes we have to enforce the dependency by a separate table to remember or model the database accurately enough. So, there are a little plus and minus about BCNF and 3NF. However, in many practical situations we do BCNF and not 3NF, but we actually choose upon 3NF and BCNF in that sense. Having said that, some of you also asked if you some practical questions about database design. Now, we are doing only basic course on database modeling. If you ever use it in any database design, practical database design situation, we will find out that even 3NF is so crisp that many queries which I like to have in this database will not be well efficiently answered by 3NF design. Therefore, we need to have redundancy in that what we do 3NF plus redundant tables, so that the answers for given very frequent queries can be supplied, can be responded to in a very efficient manner. So, we have a forum query assignment 4 question number 9. You look at the FD1, FD2, FD3 and the question was what is the number of candidate keys for the given table. Now, basically the number of candidate keys can only be obtained when you know who are the candidate keys. Now, in these cases, how do I find out the candidate key? We find out the closure of the left hand sides actually of the functional dependencies. We find out the closures of the left hand side of the functional dependencies, like we find out what is the closure of OID comma emp emp. Now, the moment I do that, what we find out is OID emp gives me branch as well, and then branch gives me department is functionally dependent on branch. So, OID emp's closure will contain the entire relation. Now, not only the left hand side of the functional dependencies, we can take the relations the attributes combinations as well. So, we can find out if I take employee and branch and find out the closure of functional dependency for both of them, then I find out from employee we do not get anything really, but from branch we get department, and the department I get OID. So, the moment I have a employee branch, I can find out the department which is functionally dependent on branch, and I can get OID which is functionally dependent on department. So, I get all 4 attributes. So, EMP branch is also if a set of attributes functional dependency closure gives me the attributes, all attributes of that particular relation, then that set can act as a primary key, provided that set is minimal, meaning I cannot delete any attribute from that particular set. So, for example, employee department. Now, from employee I cannot on employee, just on employee no attribute is functionally dependent, but OID is dependent on department. Now, the moment OID is available, then OID and employee together is the left hand side of the functional dependency branch. So, employee and department, if I take their functional dependency closure, I also get all the 4 attributes. So, these are the 3 different combinations here, which gives me all the attributes of that particular relation. You may tell me that OID emp branch also gives, if I take the closure of OID emp and branch, that will also give me 4 attributes, but then out from OID emp branch I can either delete branch or I can delete OID and still get the 4 attributes from their functional dependency closure. So, they are not minimal, and therefore, they are not the candidate keys. So, if I do this way, then I get 3 different candidate keys, and therefore, option C is correct. That's not a point. Point is, if I just give employee and look at the functional dependencies, in no functional dependency, in nothing, no attribute is dependent on employee alone, and therefore, closure of employee is a null set, not null set, it is just employee. Closure of employee is just employee. So, it cannot closure of employee is not the set of all 4 attributes of that particular department, of that particular relation. So, therefore, it is not the case. Now, this is a simple question that somebody asks, count star does it give all tuples including duplicates? The answer is yes. If you want to find out the distinct tuples, you have to write count distinct x, then that will be available. This is a very nice question actually. SQL is Turing machine equivalent language, or I mean Turing computable or not. Now, that means can I write an algorithm, any algorithm which I can write in Turing machine, can I write that algorithm in SQL or not? The answer to that question in a rudimentary sense can be given like this. To write a Turing complete any algorithm in Turing machine, we have to have condition checking and iteration. These two are mandatory. Now, iteration can be managed by recursion as well, but true recursion cannot be managed by SQL, being a declarative language. Not only declarative, it is a declarative language without recursion unless and until we include in it a term which is called CTE, common table expression. Even if you have, for example, PL, the moment you have programming abilities in SQL, like let us say PLSQL, like Oracle, Oracle C, something like where you have the programming language support which you can use for iteration, right, then it becomes a Turing complete language, otherwise not. So, ANSI 99, ANSYS SQL which was in 1999, that is not Turing complete, and primary reason is it is not truly recursive. If you want to have recursive, you have to have named procedures which you can call in a recursive manner, which can be done with the so called with clause. You have it in some slides, 1 or 2 slides I guess in your material, because this is not the focus of our class, but without a CTE, and CTE is just a concept. So, for example, we have TSQL, that is Turing complete. So, SQL must have a support for an enhancement to the recursion, only then it becomes equivalent to Turing machine, otherwise it is not a Turing machine equivalent language. This union all expression, the recursive view union all expression, that I will give you a particular, this is a little larger than we can accommodate in a 1 hour live class. I have given you a small HTML page there, but I will give you a write up in an announcement which you can follow and find out the meaning of union all, but it is basically it has a relationship with the last question. This union all with clause, that is a construct from CTE SQL with SQL, and therefore, it is a little elaborate and not so well covered not really involved in the syllabus, but that is not the point. I will give you a simple example to understand what it is, and you can follow it up further. Now, I think there are a number of forum queries for which the answers are there, and some of them are, most of them are the prospect queries. These are not technical these are not real technical queries. Whether why don't we have the practical some question. So, therefore, since we do not have the practical, those who have taken this particular course from NPTEL, they should run SQL on a machine to learn DBMS well. They can I can give them an assignment in announcement which they should do to have a grasp on the practice part of it as well. Then we have some questions like can one who is aware of C++ and Java language do this particular course? Of course, they can. Then is this certificate useful for job interviews? Yes, particularly nowadays when IICT has approved these courses as credit courses, therefore, these certificates will definitely help you, that is not a point. And similarly, is it an IICT FDP course? This is not an IICT FDP course. You can go to this slide, to this particular to this particular URL to find out which courses of NPTEL are FDP, and those courses can be done for IICT FDP certificates. but this is a core course, and core courses as per IICT cannot be courses for FDP, faculty development program. And what kind of a data in software enterprise maintain? Lots of, like human resource, like people and things like that, then finance, then inventory, then the business in which it is in. For example, if it is a software enterprise, then the customers and their calls. So, many, I mean millions of tuples are there for the data, and I think I should there are some questions you did, and the answers are there. I think you will get this particular slide here as well. So, for example, the prerequisite links, we have seen that those prerequisite links do not work. We have asked NPTEL to change those prerequisite links by new ones, and I hope that they will do it soon. The prerequisite links are obsolete, and therefore, they are not there. We have also checked it, and we are going to give you fresh links for that as well. Assignment 0 is not marked, but assignment 0 should have been done at the very beginning, to have an assessment of yourself, whether you have the prerequisites for doing this course. But since you are doing this course now, if you are doing this course now, then must be you have done this. You can do this as well. How many exams I will write during the examination? So, I think whatever be the number, that will be well inside the stipulated time frame in which you will be writing the answer. That time is not going to be a problem, that much I can tell, but exactly how many questions and things like that, that is something we do not have an idea, or we cannot say it right now. And one question is SQL procedural or non-procedural query language. I mean, SQL is called a declarative programming language, which is non-procedural. We can make it procedural by embedding SQL in procedural programming languages, but SQL per se is a declarative programming language. It is a non-procedural programming language. And so, I think we have many compilers and MySQL to run your SQL comments. You can try them. You can ask forum to get a concrete URL to check that, and I think that's all. Do I have any time? Any more time now? Any more time do you have? 2 minutes we have. So, therefore, you can take a little. For example, another question was there, which is about cursor. Now, cursor is a cursor. How can you? I think today it came, not yesterday it came. I think there is I have doubt on cursors. I did not get well about it. Now, again cursors are used to iterate on the tuples that you get in embedded SQL language basically. So, I would like to mention that I take this question, and I will also give you I need to give you some examples here. Those examples cannot be given in 5-10 minutes time frame. So, cursor is a question that I probably need to have. Do you have any other question from there that I can take? So, on cursors I will give you a write up which you can use, and if you are stuck at a particular point while writing a program or something like that, let you share that question to us. We'll check it and we'll get back to you. But in general cursors and their working, we can guide you thoroughly for that kind of a question. Compare the concept of functional dependency with the ID can functionally determine the building. For different IDs, I have still the same building. So,
indexing and hashing.
Oh, index and hashing. Okay. Index and hashing, these are used to expedite improve the performance of databases, so that your queries can become faster by that, and the ones that you have read like B3, B plus 3, primary indexing, secondary indexing, these are under this. If you have any particular question in it, then I can get back to you. And this question is very nice. I wanted to get back to it. This is a common question, the functional dependency question that I have got from Vaibhav Kumar. This is a very standard common question. I will get back. I think we have your email address. We will get back to you with exact answer for this question, because it is a common misconception that people have. What is meant by the arrow? How should I read that arrow? The arrow should not be read from left to right. The arrow actually should be read from right to left. X is functionally dependent on y, not x functionally determines y. That's so. I will clear this. I will clear this question of Vaibhav Kumar, and I will do it in a handout kind of fashion, so that everybody can come to know about it. It's a common question. I'll so don't worry. Will give that announcement by tomorrow to all of you, all those who are enrolled in this particular class. So thank you very much.